Hello, everybody. I appreciate your being here today with me, ladies and gentlemen. I would like to kick things off with a little personal narratives that captures the essence of strategy, wit, and, well, a little bit of mischief. Every weekend, we have a treasured tradition unfolds in our home, and it is board game evening. Now imagine this. It's a cozy Friday evening. The Carcassonne is one of our favorite game. Tiles are carefully spread out, and we are all lost in the race for the win. In the midst of the competition, a 7-year-old savant emerges among the race for these points. And of course, it's my son. A clever strategy in the making. While we stake our claims into cities, roads, and farms, he artfully pretends to have misunderstood the rules or casually overlooked the placements that made by his older sister and, of course, me. Without him noticing, of course, we are onto his subtle maneuvers. Now you might be wondering why I'm sharing this story at this conference. Before answering this question, right here I'm having 3 merchants from the sponsor, which is our Gortum. For those first 3 persons who can spot what says wrong in this page. This is actually a game in our home. This is not from the internet. There is something so wrong in these tiles. So which one? Which one? The central one. So we got 1 merchant here. Anybody else? Have you noticed? Sorry? Okay, the second one. No, it's fine. It's fine. No, it's not the river. There is well. There is a bridge up on it. Yep. No, that was one here. Dry code. Which one? There is 2. Yeah. Yeah. Give it like 30 more seconds. Sorry, I do remember you. No worries. I will share the slide at the end. I will keep the 3rd merchant for myself. Thank you. So, if you really look closely, you will recognize qualities that are just important in the world of software engineer as in the board games. In the world of software engineer, like a game of Carcassonne, we encounter unexpected challenges, changing rules, and occasionally touch of this mischief. Because this is actual game from my son, I bet my son when he grow up, he will become a product owner or a business analytics, for sure, for the business logic. Today, I want to share with you some of the strategies and blueprints for building software that I have had experience within my over than a decade software engineering career. My name is Mahmoud. I've been building software since I can remember for more than 13 years. I've been helping business to reach their goals for the business, growth, and whatever the goal that was, been helping them. And currently, I'm a lead software engineer in one of a world-class company that calls Gortum. It is software solutions for telematics. And currently, we are in the market over than 20 years. We have our headquarters here in Vilnius, Lithuania, and we're having 2 more offices, one in Boston and the other one in Georgia. And we're having a dedicated team that is working from across the globe. We currently having 3 products that are outstanding and serving more than 4 million vehicles and stationary units across the globe. Getting back on track. So what is actually resilient? So there is a rough but imperfect agreements about what the term of software resilience mean. I personally observe it as the capacity of software systems that continue functioning even only if partially in the face of unexpected events. This is essential because no matter how well our system is designed, unexpected challenges are bound to show up, and it's not guaranteed that everything will be fine. Resilience has not been defined by any of the standard of software quality products out there in the internet or in the other organization. However, there are some synonyms, quality attributes, most of them that meets the closest of the resilience. The dominant model for software system product quality defined by the International Organization for Standardization defined, and it breaks it down into 8 characteristics and sub-characteristics. These characteristics cover things like functionality, reliability, and observability, and efficiency and maintainability, and others as well. Reliability is the one that, based on the International Organization for Standardization, the one that falls under which the concepts of resilience fall. The sub-characteristics under reliability must align with typically descriptions of the resilience. And I personally, if you can see that there is 3 first letter, this is something that I would like to have, which is the key point that I can remember, which is FAR. I personally observe it as a marathon, not a sprint. So this is something that should be going and going and going. So it is basically the fault tolerance, availability, and recoverability as well. These characteristics and sub-characteristics provide structured way to measure and describe the different aspects of software performance. The characteristics mentioned by the International Organization for Standardization are very closely related and defined by 3 items, and they which are falls into 2 categories. One of these items fall under the business objectives, and the other one under the engineering side as well. Under the business, we see that it has the main item, which is requirement maturity, which we need to be careful before doing anything in the system by coding, designing, architecturing, no matter what. We have to have a solid requirements by the business. And on the engineering side, we're having 2 things, other items that falls under it, which is the good architecture and the good practice as well. So we are not going to talk about the business in general. However, it's really crucial to understand and to be aligned, because if we don't have any business requirements that is solid, then we have nothing to be working on the engineering side. So one of the things which is really challenging, which is the service level agreement. This is basically a promise between 2 parties. These 2 parties, if you're working or if your company is B2B or B2C or B2B2C, there is a lot of other communication and business modules. It outlined the specific expectation and commitment between these 2 parties and who's are accountable for what. Unfortunately, there is one challenge that I have came across, which is most of the time the service level agreements are done by the business guys and the legal team as well, without or no at all involvement from the engineering and the tech team, which doesn't meet the actual reality in our world. So to avoid this, it is important for the business, legal, and the legal team as well to collaborate with the tech teams before defining any of these to make sure that we are all aligned and we are all working towards one goal to reach. The second one, which is pretty much related to the previous point, which is the service level objectives, which is the actual numbers that you define by the business, how much percent that we want our service to be available. For instance, Google provide like 99.99% of the service to be available all the time. And this is why it is Google now. It's not actually not only this, but this is one of the reasons why we're using Google Cloud and AWS and other FAANG company. SLO are typically expressed as a percentage or specific number, so we need to be sure we are having these numbers before putting our plan. And we're having the recovery time objectives. It's basically like a clock watch, so how fast or how quickly we want our system to get back when something bad is happening to our system or to our software. And the last one from the business objectives, which is the recovery point objectives, which is basically a snapshot timers of your data. If some disaster happen, how willing are you to lose and how much data are you willing to lose? Because you cannot control everything that around you. If you're relying on other service or other provider that located somewhere in the world, you have no idea there's something that really bad could happen to them. Switching to the engineering strategies. There are three things that, there is of course like more than these, but these are the things that I found it essential that and could be implemented pretty much in all the solutions that we're building. One of them is called phased rollout or incremental deployment. Basically, it could be done by one of the deployment technique. There is a few of them that they call it colorful. So it is canary, blue, green, feature flag, and you name it. So there was an example how this looks like. So the rectangle represents a service, software, component, whatever that exists in your system. The yellow one that represents that service, which is the legacy, the existing current solution that is already working at the moment. The purple one is something new that you want to migrate to or you want to implement in your system. The green one, which is everything seems to be fine. The red one that seems to be everything is bad. And this, how much user that you're having, this is your user base that you're having. Now, without having phased rollout or incremental deployment, if you switch from the yellow to the purple, which is the new service, if something bad happened, boom, we're all out. We're going to stay at the office, eating pizza, drinking beer until we fix this one. We're not going home. And instead of having like 100% of the deployment at once, actually what you need is, you need to keep the legacy or the existing system in place and just like deploy only 1% for 1 week, for 1 month, for 2 weeks. Every business knows his requirements and needs. However, if something happens, it will happen only to 1%. It will not happen to every other users that in your system. If you're having like 10 million users, they will all be affected. If hundreds will be facing an issue in your system, I mean, you're having like 100 or 10 million. This should be fine. We need to mitigate it. When you face this in 1%, you fix it, everything seems to be fine. Then you keep going. I'm gonna roll it out for 5%. 5% is fine, cool. I'm gonna keep it like 10, 15 and keep going. Unless you're having to the 100% and everything seems to be fine and you are safe and your system keep going and it will not fail. So this is one of the strategies that you need to be thinking about if you are not implementing at the moment. There are a bunch of other things that you can be doing to have incremental deployment. Another thing from the technical point of view, which is called a circuit breaker. So it is engineering concept. So the electricity not going way too bad. So one of the things in the circuit breaker in the software engineering, it's basically safety mechanism that prevents failing components or services from continuously causing issues in your system. And there's another example. Say you're having the forecast an application, and this forecast is talking to 3 more services. This is what the flow could look like. This is your user. He goes to your application. He looking for whatever weather for today, and it's snowy outside. I love it personally. What will happen, the application will send to one service will send to another, and keep going. So this is how the happy path look like. The negative path will happen if one of the services that the other services are dependent on or component dependent on. If it will fail, so things will go back. I love this emoji. I love Windows. This should be bad face, sad face. So this is actually the user, his sad face. So let's have this as a sad face. So the service failing or becoming unresponsive, which is something that we don't want to do, because we want to keep our user satisfied with the system that we're building. What you need to do is one of the things, which is the circuit breaker. So basically, it acts as a guard. It monitors your components or services if something happen and repeatedly occurring issues. It just like trips and prevent further failure requests to keep going in your system. So the circuit breaker has 3 states, which is closed, open, and half open. Others are calling the half open something else. So basically, the closed state saying everything is fine, the loop is fine, it's closed, our request is going back and forth, and our customer is happy, just like keeping normal requests keeping through. The open state, there is a certain threshold defined by the business. This is why we covered the business side and the business objectives. So there is threshold which is defined by the business. When it's reached its limit, so basically it switches to the open state and saying, hey, there is something wrong, stop sending any more requests to the service that is failing, and just like stop, don't do it anymore. This avoids the overloading for the service, because if you are using AWS, and you will just like be paying a lot of money because they are seeing how many are you consuming of these services. Half open, basically, I see it as a tester, or it just like not sending the requests anymore. It just like sending one request to the service that is failing to test it. If everything is fine, so then it goes to the closed and everything is fine back and our customer is happy. However, if it's still failing, it just like remains in the open state as well. The circuit breaker could be implemented with another pattern or tactics of the software engineering, which is the fallback pattern. So you can implement, if the service is still failing, you can say, hey, give me the cache, the last request response from the cache, where you actually have a standby service or a component that gives you the actual response for the time that the service is still failing. Disaster recovery, this could be anything that is happening within our control or without our control. This could be a server crashing, virus attack in your code, or even natural disaster like a flood or fire damaging your computers. Disaster recovery helps you bounce back quickly. There is a few types of disaster recovery. There is a few types of disaster recovery, and there are some of them that you have to make sure that you're having a copy of your software or your code or of your data on a regular basis. And you have to have a server ready in case if something is happening, you need to switch back. It's just like basically like a spare in your car. If one tire just like went flat, you will not stay in the middle of the road and just like bump it up. You will just like change it and keep going. So there is a few key points for planning a disaster recovery, which is You need to recognize what could go wrong, and just like a hypothesis in your system or in your business, determine which problem are most critical for your business. If, again, back into the scenario, if you're having 10 million users and 100 of them couldn't log in into your system to have a payment or something, this critical, or it's fine, we can mitigate it, we can tolerate it. Conduct drill stimulates, you need to break your own system by yourself in test cases, and there is the next one that we will go and we'll cover it together as well. And you need to update this disaster plan because things are changing on the time and you cannot stay still. The incident management, which is experiencing some downtime. And sure, most of us as engineer back, I remember when I was actively coding, I could sneak, fix it without let the business knowing about it, and I kind of hustle and just finger crossed that everything will be fine and no one will notice. This happened, yeah, those who's laughing, he did it, you did it, I know, I guarantee. So that's bound to lead some frustration and complaint within the team and within the organization. So with the affected people, to let them know about the incident, that proactive communication builds trust and keep everybody in the loop. So we are all know what is going on in our system. So what we need to know, what we need to do in our incident management, we need to define channels and procedures for reporting incidents. So everybody within the stakeholders and those who are the leader within our organization. Form a dedicated incident response team. You have to know your people who is responsible for what. Just like if something happened, we will all be running across the office and just we don't know what is going on. So you have to outline who is responsible for what. If someone, he can leave, go to another company or something, you have to have a backup for him as well, because you cannot guarantee there is someone that will be staying forever. You need to establish communication channels and protocols who are responsible for the communication, because us as engineer, I only have 2 hands. I cannot fix the problem. I cannot go communicate with the stakeholders. I cannot go and test it. So you need to define who is responsible for what. Implement a system for categorization the incident based on the impact. This internal incident, this external incident. An incident could be that you're deploying something and the pipeline didn't pass. This is an incident, but the customers are not affected by this. If the page, just like I went to the website or the mobile application, if it's just blank or white page, this is affected by the customer. So you need to outline this is how critical is it for your business. And again, you need procedures for diagnostic and resolving incident efficiently. This predefined steps and checklists and playbooks. When something happens, you have to have a template. So I just go copy and keep going to fix it. Because sitting there and having an email or having a checklist of what I need to do when something bad is happening will take me 30 or 60 minutes to fix it. So you have to have your things ready beforehand. And of course, you have to conduct a post-incident to review and analyze and the root causes. This is actually a pretty important point to keep, because we need to use it as a learning opportunity. So when something bad is happening, it is happening. So we need to learn why this is happening. So we don't need to avoid it. We have to outline, we have to gather and see why that happened and what was the root cause. And of course, you have to have your archive of the incident, because if you're having a new guy came to your company and from his first day, this happened to me, from his luckiest day, just the production went down and you didn't even touch the code. So you just go to the archive and see, did that happen before? And if it's happened before, so what was the steps that was followed? So I follow and fix the problem. And one of my favorite one, which is the chaos engineering. So the chaos engineering is a proactive methodical strategy to increase system reliability by introducing controlled disruption on purpose. So I love this. I love when things went like red all over the place. I love it. I'm just like, I'm staying in the middle of the room and everything is breaking, is not working. I love it. I love this pressure. So it promotes resilience, continued development, and learning culture within the organization, ultimately resulting in more robust and trustworthy systems. So there is one, this is what I know by far. On the infrastructure front, you might have heard of Netflix's infamous Chaos Monkey. This bold monkey just like goes to your production and start shut down instances to see how your system is resilient. It serves a sort of stress test to your software. It pushes your system to the limits, unveiling just how well the weather will storm when the chaos strikes. Chaos began with forming hypotheses, so what could go wrong again? So if we look into all of this, we just like pretty much they are all linked to each other. So it is forming with hypotheses about how a system might fail or behave under stress. Controlled experiments, so these are the key components that we need to think of when we think about the chaos engineering as well. This could involve stimulating network, outage, hardware failure, increased system load, or observe how systems respond. A crucial aspect of chaos engineering is the use of monitoring and observability tooling. Of course, this needs to be from the day one in your system, because if you don't have this, you have no idea if your system is failing or not. Chaos engineering typically conclude gradually and incrementally, starting with small-scale experiments. So don't go and just like shut down everything, at least one service or one component, to make sure that you are controlling the whole scenario. And instead of viewing failure as a problem to be avoided, you need to treat them as a learning opportunities. And finally, achieving quality is not a trivial task and is not with low cost. It requires a number of proper training, discipline, and monitoring, and it should be considered from the very beginning of the software development process. And to wrap up, for those who just like came to Lithuania, is not based here, thank you for sharing, for everybody, thank you for sharing the space with me, and I look forward for the resilience that you will bring to endeavors. Safe travels on your ongoing journey, and may your system remain robust and software always. Thank you.
All right, folks, we have a bit of time. Do we have any questions?
Yes.
Yes.
Oh, it was me.
I'm not very good with microphones, but do you believe that there is a thing like too much attention to resilience, backups, and recovery stuff in development, and like the differences, between what user is actually getting from the development processes and how much time and effort is being produced for the development team to actually be resilient on the systems?
It all depends on the business, to be honest. If you are building a blog, just like for articles, and you're making like $100,000 per month, and if it's working and it's in WordPress, fine, you don't need to be worried about this, because you're having your repository, you're having database, just like copy, paste, put it on another server, and you're fine, and you're good to go. But if your business is complex, say, most of the business that requires login system or registration system in your system, right? So it's just like pretty straightforward. You're having your email and your password, and you're good to go. But other business, they are having a marketing strategy that leads, it's like IKEA basically. If you want to go buy one thing, you don't go and buy this one thing. They will take you in the whole store to get to that thing. This is a marketing strategy to make you just like go and walk through and buy things that you don't need. And for that reason, the same in the software, you really need to be, you have to be prepared beforehand even for the developer. And actually, it is for the developer, it makes them more confident, I would say.
Yeah, and that's for sure. Like, but I myself had like a couple of projects that had really strict deadlines. They were developing from the beginning, and it was actually quite an important systems. And it was on our end, on the developer side, that we needed to prioritize like what is the actual.
Got your question. This is why I split them into two categories, which is the business objectives. If you don't know what the business need and what is the business aim for, so there is no absolutely reason to do what you're doing, right? So if you know and fully knowledgeable of what the business need and what they need to be doing to their users, so based on that you will be keep going and you plan what you're going to be doing. So yeah, I know I've been there. I've been writing a lot of things that is just like waste of time and it's not needed because I had no clue what is the business. Yeah, I know my business. I don't know, it's just like cloud solution for whatever reason. But actually what I'm doing does not meet the business requirement. So this is why I mentioned the business objectives to be first and they have to link together. Did I answer your question? Okay, there's your back.
Oh. Yeah.
Sorry.
Hello. Thank you for presentation, and you forgot to show us the picture. The right answer.
It's not me, it's that guy who presented.
Yeah, so could you show it or at least tell it?
Yeah, I can see it on my
Thank
phone.
you.
I don't know if you can see it on my phone.
Thank you. While we dig out the picture, folks, do we have any other questions?
Yeah.
There you go, look, you've achieved complete enlightenment. Oh no, we have one more.
Sure.
Hello, thank you for your presentation.
Thank you.
And I would like to know your opinion about the incident management plan that you are talking about. So, what about incident that consequences are not faced user? So, for example, we have some kind of increased load, and but still it's not facing user. Should we also apply this plan for to solve those incident and somehow to build metrics and react and plan in quarters to fix some kind of stuff to not have incident which will face user?
Yeah, sure. So there's one of the points was, I don't remember perfectly, that it was categorize your incidents and whose is impacted by. So it is internal, so it is us who's doing the code and something is happening and I know about it. So again, you can go and fix it and just like finger crossed that no one knows about it. But this is bad because your colleagues say, I've been working in organization where we had dedicated team for each service or each domain in the business, right? And we were like 8 teams, and for each team, so we had about like 20 team members working on their own domain. If I fixed something, they have no clue what is happening, and they are relying on me. So I believe we should be applying this as well. Applying it for one reason, to keep everybody in the loop, and they know that there was something happening, and we fix it, and this is how we fix it, because they might be seeing this. I've been seeing this a lot, pretty much a lot. So you have to categorize it in this. Yes, if this is something, say like in our term, like hot fix, this is for the customers that who's facing. It's like the whole organization need to be aware about this and need to be aware about it. So I believe yes, because if you're having one guideline for everybody, you will be good later. You don't have to be worrying about who I need to tell and how this will be done. So yes.
All right, folks. Any more questions? Yes, down the front.
Yeah, thank you for your presentation. And you told like right things. I'm ready to sign for every line. And I'm totally agree that these strategies, these approaches should be like, implemented in every project for sure. But in real life, nowadays, we come for existing project, as you can for Gotham or like for other company. And I think that for many projects, everything is not so good with like monitoring, observability, and all this stuff. So my question is, can you like summarize or give some recommendation where to start to in this journey to reliable software for guys who come for new projects?
I've had experience with the following, and I kind of summarize it in this way. So most out of the organization out there, they are hiring engineers and specialists for the project needs, not for the business needs. So if I'm having, say, I need a backend guy who can write Python, Java, whatever the language it is. So I'm looking for the language. I'm not looking for what this guy is capable of and what is expertise in this area, right? So I would start with the business. We have to talk, and when we have to say we are missing things. If you see the organization is missing this part, so we have to raise our hand as, hey, we need training if you really care about the business. Just like we need training in this area. If it's not available in your organization, they can provide it, then we can go outside and ask, and we can go outside. Because if the business care about it, they will provide it to you. If they don't care, just like they don't care. So I don't care either, right? So I will keep moving, keep going. And it depends on the person who's building this. So I would start with the business. Definitely, the business is just like the solid foundation for any requirements. Resilience, no resilience, doesn't matter. So the business as a foundation. And after the training, of course. So we need to train. There is a lot of trends that is happening. We need to be following these trends, right? So this is one of the framework that was done by the Netflix, the Chaos Monkey. It's a great tool, just like great tool. But it doesn't work for any system. But it is out there. The circuit breaker, I know it is almost in all the languages in the back end. I'm not sure how it's working on in the front end as well. So we need to be evolving and know about we need to keep going and learn more things. So business and learning, I would just like sum this up.
All right.
Sorry, you found it? I will give you immersion in a way. So the rules are simple. I'm afraid to fall. So the rules are simple. Basically, it is, as you can see, it's a castle, roads, and rivers, and everything. So each tile has to be connected to its part. So this is a wall. This is a wall. I cannot put this wall into this green. So it has to be connected like this wall. This is one. So this is actually one. The second one is this. The road is not connected to any of these. So these are not right. So this road has to be connected like these roads. And this is not right. Yeah, just like stop the game. Or just like don't play with your kids. Yeah.